Hi, my name is Mike Appleby. I'm from the Yale Center for British Art at Yale University, and I'm going to talk a little bit about the IIIF APIs and give you some demonstrations that hopefully relate the APIs to what you've seen already, with a couple of new demos thrown in. Sheila showed this slide earlier with the image API, and it gives you an example of how the image API allows a software client to request an image or a region of an image. In the example shown here, a request is made for a specific region of interest, in other words, the face, and then the rest of the URL defines how that image should be scaled, flipped, rotated, and changed to grayscale. And then finally, the .jpg extension indicates that that image should be returned by the server to the software client as a JPEG. So some interesting applications are can be constructed using just the image API. And I'll give an example here of a small program developed by the Victoria and Albert Museum. The Victoria and Albert Museum has a sketch shown on the right of an oil painting that is held at the Yale Center for British Art. And we also, at the Yale Center for British Art, have an oil painting that is a sketch or a precursor to the final painting. And so the Victoria and Albert Museum has developed software that pulls the images from both Yale and the V&A and allows them to be brought into one tool, which then allows the images to be overlaid and cross-faded, and then the user can align the images, scale them, and adjust the alignment in order to overlay them or register them. And the goal of this is to show the difference in the composition as it changes over time from the sketch to the next sketch to the final painting, and you can see the differences kind of more clearly as they are as they're overlaid. And they use this application then to drive a rendering online on their site, which again draws the images live and requests the overlaid images in the correct dimension and the correct region. I'll talk a little bit next about the presentation API. The objective of the presentation API is to provide the information necessary to allow a rich viewing experience in a software client, likely in conjunction with the IIIF image API. The core or central object really in the presentation API is the manifest. And the manifest contains the data necessary to represent an object. It contains the structure, the sequence of images and so forth, and also metadata that's intended to be displayed to the user. So not structured metadata, but display metadata. Another central concept of the presentation API is that of the canvas. The canvas is a blank canvas or a blank area, and the images to be displayed in that view, in that particular canvas, are associated with it via annotation. In the presentation API 2, we use the open annotation specification. In the coming version of the presentation API, we will use a W3C web annotations, which is a W3C standard. Each manifest that represents the object contains one or more sequences of these canvases, and each of those sequences gives you the sort of page order view that you would see sort of at the bottom of the screen, or if you look in Mirador across the bottom, or in Universal Viewer down the side of the screen. The presentation API also contains many other properties that can be used to provide a label, description, thumbnail, technical information, including the viewing direction, and links to external files or external websites. So a link to your online catalog or a link to a metadata file. Work is currently underway on presentation in API 3, and this will include support for audio and video. So in addition to having an X and Y axis, each canvas will have a timeline that will allow annotations to appear at different points in time. Now, let me talk about one of the examples we've seen, which is the reunification of this manuscript that has had the miniature cut out. What does that look like in terms of the API? Well, we have a canvas, and the image of the page is annotated onto the entire canvas, and the image of the fragment, or the miniature, is annotated at the appropriate X and Y coordinate to fit the gap, and the height and the width are specified correctly so that that image is scaled to fit in the hole in the page. And the result is this demonstration that you've already seen twice, which is that the miniature can be turned on, and it will load separately into that space defined by those coordinates. Another approach is to use multiple images that target the entire canvas. This lets you build a sort of a stack of multiple images that can be turned on and off. So similar to the example that you saw earlier from the National Gallery of Art, with the woman in the red hat, here's an example from the Yale Center for British Art, where we have an X-ray version of the painting, and we can turn on a overlay that is a conventional photography, and we can adjust the opacity of that, so you can then start to see some differences between the X-ray version and the visible light. And if we zoom in and adjust the opacity again, you'll see around the head that there is a hat or a bonnet that's visible in the X-ray, but it's not there. It's been overpainted, and it's not visible in the conventional photography. And now a final example is just to show you the power of the deep zoom. We have a canvas. The underlying image is about 6,000 pixels across, but we can annotate a very high resolution image into a very small area on the painting or on the canvas. So we can annotate a 5,000 pixel image into a very small area. And viewers like Mirador will allow you to zoom in completely on those detail images. So again, here's another painting. We have many detail images as well as some UV and IR. And we can just turn on the various detail images, and they are overlaid. See that, and then we can zoom in to a very deep zoom in to the full resolution of that small of the image that was annotated onto a very small area. So it's a very powerful capability for overlaying these types of images. And as you can see here, again, as with the X-ray, if you have multispectral imaging or other types of imaging, the ability to crossfade can allow you to detect changes that you might be interested in. And with that, I think I'll thank you very much, and I'll hand it over to my colleague, Sheila Rabin.